Hey there, everybody. We're going to talk about the first derivative test and what it means and how we can use it. So first up, increasing and decreasing. So this is the first idea. So I'm going to give you a function. So I have a function. It is increasing and decreasing. So let's look at where it's increasing and where it's decreasing. So first up, from the start of the interval all the way up to its maximum, relative maximum right here, and we would say it is increasing. And then the next time it is increasing, it's during this portion. Now, where is it decreasing? It is also decreasing. We're going to do that a different color, a little bit of blue. This is decreasing. Well, decreasing, if you think about our derivatives, this would mean f prime of x is greater than 0. This would mean f prime of x is less than 0 or negative. And this would mean f prime of x is greater than 0. So here's what we could do, and this is what I want to encourage you to do, is to draw a number line. And what we'll do is we will do all of your critical points. What is a critical point? Critical point is when your derivative equals 0. And so we have a couple spots in here where the derivative is 0. Derivative is 0 and the slope is 0. And so we have these two little unique spots where the derivative is 0. And so this number line is going to represent my derivatives or my slopes. I want you to think about it both ways. And so if it represents my slopes, this slope right here is going to be negative. And so one of the ways I could write that is that this is a negative slope. Then during this portion it is a positive slope at the end, and the beginning is a positive end. And these points are where it is 0. And these are what we refer to as the critical points. Okay. Now, the first derivative test. Here's what the first derivative test says: that if you have a point where the first derivative equals 0, and we call these critical points, that if the slope beforehand is positive and the slope afterwards is negative, we would refer this as a, let's go look. So here it's positive beforehand and then negative. Is this a maximum or a minimum location right here? This is going to be a maximum. Now this is very important. It's not an absolute maximum. We would call this a relative maximum, because it's not a maximum guaranteed for everything. It's just a maximum right there. Now let's look at our next spot here, our next critical point. Well, this critical point here, if you look, before it is negative slope and afterwards it is positive slope. And so we say that this critical point, if I look at my graph there, is a minimum. Your book has a much nicer way of describing it, but that's the guts of it. That's what your first derivative test does for you. Now, once again, these are not maximum or minimums absolutely, but they are relative, because if you look around them, they are the minimum right here and they are the maximum right here. Okay, and so if you draw one of these number lines, you'll be able to see how that behavior changes from increasing to decreasing or decreasing to increasing. Now, there is one graph, we'll put it right here because I need some space, is what if my graph did this? Okay, this right here, right there, has a slope of 0. Well, that is a critical point because your slope is 0. But let's look at it. Before that point has a positive slope, after that point has a positive slope. And so we would say that this has no relative min or max. Okay. So what we're going to do is we're going to do this with an equation. Find the critical points. Let's give you an equation. Let's say I got, probably should have thought of one ahead of time. I dreamt one up here. Y equals x squared minus 8x plus 9. Well, first thing we do is we take the derivative. Y prime is 2x minus 8. Next step, find the critical points. So to find my critical points, that's where the slope is 0. So y prime equals 0. So 0 equals 2x minus 8. So x equals 4. Now, create my number line. My critical point is x equals 4. And then I look and I see what is happening on both sides of that. So I'm going to plug in a test point. I'm going to plug in a test point. An easy one for me to plug in is a number smaller than 4. A number smaller than 4 is 1. So I'm going to plug 1 into y prime. So what does y prime equal when I do 2 times 1 minus 8? So y prime equals 2 minus 8, which is negative 6. So right here I have a negative slope. And I plug in another test value with a number bigger than 4. 1,000. Could I have used 5? Yes. Could I have used 10? I can use any number. But if I had another critical point up here, I would have to pick a number before that. So you can either pick a number close to it, or you can pick a number way big, and then you don't have to worry about it. I do it both ways. 2 times, let's just do 5, because you wanted that. So y prime equals 10 minus 8, which is 2. So the slope is positive afterwards. Now, so if the slope's positive, so let's think about my function. It's decreasing and then it's increasing. So if I were to draw my function, and when I'm at x equals 4, my function is decreasing, levels off, and then it's increasing. Do I have a max or do I have a min? I have a min. Because that's going to be the point, because if I'm decreasing, my graph's going down, and then I'm increasing, so I have to have a minimum value. So I would say I have a minimum at x equals 4, a relative minimum at x equals 4 by the first derivative test. All right, everybody, I'm back. So here is my situation. Here is a graph of the first derivative. Describe the function. So this is a very classic style of AP question. So let's walk through it. So create a number line. Plug in your critical points. Critical points are when your first derivative is 0. Here's a first derivative of 0. That's at 1. Here's another point where the first derivative is 0. And here's another point where the first derivative is 0. Notice, this is a picture of first derivative. This is not f of x. It's very important. This is a picture of the slopes. So let's look at my behavior. And so my behavior here is before negative 1, my f prime is greater than 0. So I would say it is a positive slopes, positive f primes. Between negative 1 and 0, I have negative numbers. 0 and 1, I have positive numbers again. And then after 1, I have negatives. So what's my graph doing? What is my function doing? So let's think about this. What's happening at x equals negative 1? X equals negative 1. F prime of negative 1 is 0. So my graph's flat. Now, if I look before, my graph has a positive value, because I have a positive slope. After negative 1, I have a negative slope, so what do I have? I have a maximum. Now, it's not an absolute maximum, but I have a relative maximum. In other words, in that little general area, it's a relative maximum. Now, let's look at my next one. Let's look at x equals 0. Well, at x equals 0, f prime of 0 equals 0. Because if I look at, this is a picture of my first derivative, I'm at 0. It's a point. Now, if I look before, my slope is negative. Before I get to this, it's negative. Afterwards, it's positive. So I'm going to draw a negative, and then afterwards, it's positive. So what is my function doing? It has a relative minimum. Okay. That's the word relative, that's the word minimum. I promise. Alright, here we go. Alright, let's do this. I'm gonna change the slides and I'm gonna make you a problem. This is the most classic AP problem ever. So let me draw it up, and then we're gonna walk through it and think about it. Here we go. So take a second, hit pause on YouTube, pause. And then when you come back, here we go. So you're given f prime of x. This is a picture not of the function, this is a picture of the slopes. And so here, if I look at my first part, I have my function is increasing. My next part, from 2 to 3, my function's still increasing, it's just not as much because I still have positive first derivatives, positive slopes. Yes, even though this slope is negative, that means that my function is still going up, but it's leveling off. When does it level off? At 3. And at 4, is it leveling off? It's not leveling off at 4. At 4, the derivative's leveling off, meaning the slope is staying the same, but my function has a positive derivative right here, because this is a picture of my derivatives. So I have a picture of my derivatives, and I've got all these points where it's a positive derivatives, and then I finally get here where I'm negative. So let's look. Where are my critical points? My critical points are at 3. My critical point is at 5. What is a critical point? A critical point is when your first derivative of a value equals 0. And that happens at 3, and that happens at 5. At 4, my first derivative is not equal to 0. It's equal to some number, like 3. I don't know, whatever. Right? So now I look at my behavior. Before 3, it has a positive slope. After 3, it has a positive slopes because they're positive first derivatives. After 5, I'm negative. So the question would be, where are all the relative extrema? The relative extrema happen at, let's look at my two critical points where they could be at. Could it be at 3? No, it can't, because it doesn't change before and after. Now, what about at 5? At 5, my graph goes from positive to negative. And so if I drew a picture of my function, at 5, it's going from going up to going down. So this, you didn't see that. Okay, let me step back a second. This is a picture of my function, and it goes from positive to negative. And so if it goes from positive to negative, that means I have a relative maximum. Okay. Let's look at 3. Let's look at f of x around 3 when we're at 3. So let's think about when I'm at 3, it says I have a positive slope, and then what is it after 3? More positive slope. And so my function is going up and up. And so at 3 here, do I have a max or a minimum? No. But what I do have is I have a spot where it's flat. Very important. As we get to the next section to talk about inflection points, remember that special spot, because if you look at it, your graph is changing something. It's just not a maximum or a minimum. Classic AP problem. And so, all right, let's leave it at that for now. We'll get into more at the end of 3. All right, keep it up. Keep tubing in, I should say.